And here we continue with another mind map for chapter 8, the magnetic fields of moving charges. So this chapter is dedicated for grade 12 advanced students. So as the first section, we are talking about the Biot-Savart law. So these are two scientists who work together and they find out or they study the magnetic field created by current going through a wire. So the current in the wire produces a magnetic field around the wire. We continue the second section where magnetic fields due to current distribution. So the equation of the magnetic field around around the wire is equal to mu 0 multiplied by I over 2 pi r. So mu 0 is the magnetic permeability, which is a constant, 4 pi multiplied by 10 to the power of minus 7 multiplied by the current I, current going through the wire, over 2 pi r. R is the distance from the wire. So every time you are away from the wire, the magnetic field will be less. So we continue the third section about the right hand rule. So the red arrow represents the current. Okay, so it's parallel to your thumb, first finger, and the four other fingers give you the direction of the magnetic field. So every time you have a current going through the wire, you can define the direction of the magnetic field by applying the right hand rule. So we continue the last or before the last section about the two parallel wires. So if we have two parallel wires, of course, each one of them is affecting the other. So we can calculate the magnetic field of the first wire by using this equation. So it's very similar to that one. So it's again mu 0 multiplied by I1, which is the current going through the first wire, over 2 pi d. D is the distance between the two wires. Of course, there is another equation for the force created by the magnetic field. It's equal to mu 0, the magnetic permeability, multiplied by both currents, I1 and I2, multiplied by L, which is the length of the wire, over 2 pi d. Again, d is the distance between the two wires. And we come to the end of the chapter with the magnetic field at the center of a loop. So here we don't have a wire, but we have a loop. So again, the equation of the magnetic field created by that loop is equal to mu 0, which is the magnetic permeability, multiplied by the current I over 2r. R is the radius of the loop. Thank you for watching. Thank you for your attention, and see you with the next videos.